further with code, I want to take a step back. I like to do a little code at the beginning just to make things real, so you're not just hearing a story about, some abstract features. But before we continue with the code, I want to talk a little bit about what Spark is. Let me actually zoom this in just a tiny bit. About what Spark is and roughly how it works. So what is Spark? So Spark is a distributed data parallel compute engine. And it's got a lot of other pieces on there like we've been talking about just to make life easier. But the key pieces are distributed, meaning across lots of machines. And to drill down on that a little bit more, it's not enough to just put work on more than one machine, right? If you don't do it exactly right, you can end up with a situation where you're throwing more and more servers at a problem, but you're not really getting more and more results. So what we want to do is make sure that as we add more servers, our results are scaling linearly with the number of servers. You can think of this as meaning if you multiply the number of servers times x, you should either be able to process the x times as much data, or you should be able to process your original amount of data in 1 over x as much time. So those are kind of two ways of thinking about linear scalability. So that's a really important feature of Spark, and there are many workloads today that run in the tens of thousands of nodes on multiple petabytes all day long. So Spark does scale linearly into tens of thousands of nodes. Spark is a data parallel compute engine. So data parallel is one of the models for doing parallel computation. The idea is that we take our big data set, we describe it as a bunch of separate chunks. In Spark, those are called partitions or blocks. And we run the same code over the different partitions. So for example, if we're trying to find customers in New Jersey out of a trillion customers, well, I guess nobody has a trillion customers, but if you're Facebook, you might have a billion customers. We could take our billion customers, divide them into chunks, and run that operation where we check to see if they're from New Jersey simultaneously over each of those chunks. And the last part is compute engine. So, well, of course it's doing compute, so why do I even put it there? Well, what I'm emphasizing here is that unlike a database, Spark doesn't manage its own storage, right? So many systems that handle queries like this operate their own storage in very clever ways, and that's great. Spark doesn't manage its own storage. Instead, it talks to any kind of storage you have. So Spark will talk to databases like Oracle or Mongo or Cassandra. It'll talk to flat files like CSV or JSON, and it can actually look at all of these at once and even join them and use them in the same query. In terms of file system, it's also very flexible. Your data could be in S3, it could be in HDFS, which is the way it's commonly done on-prem. And while Spark doesn't control how you store your data, it's happy to talk to all of those sources and try and optimize as much as it can. So